everyone, my name is Alexis Segoviano and welcome to our lab report presentation. I am in Group 1 and my team members are Anaí Ramos, Priscila Rodriguez, and April Todd. So for introduction, for our first physics lab, we explored how charges are created and how they interact with one another. Interaction of charges are something that we encounter in everyday life but don't take much notice of. For an example, when you rub a balloon on your hair, it causes your hair to stand up because it's attracted to the balloon due to friction. Another common example is static electricity, like when you touch a doorknob or even jumping on a trampoline and touch the metal, we feel a little spark. In our experiment, we didn't use a balloon, but instead we used tape as our main material. By pulling off tape off its surface, we created charges, and then we observed how the tape interacted with different objects and with other pieces of tape. The goal of this experiment was to analyze and confirm the principle that like charges repel and opposite charges attract. So for our materials, in this experiment, our materials consisted of a roll of clear tape, a metric ruler, a pen for labeling, a paper clip, pencil, and a planner. So for our procedures, in part A, we started cutting one strip of tape about 40 centimeters long. We stuck it down, the sticky side down onto the table, leaving a little tab so we could peel it off. After pressing it down firmly, we quickly pulled the tape off the table. This gave the tape a
Okay, but
charge.
I can't tell if this is
Next, we
wind
tested
or
how it
air or
interacted
is
with
this.
different objects. We also held our tape near our finger, a paperclip, the planner, and a pencil, and we wanted to see whether the tape would attract or repel each item. For part B, we used two strands of tape and also 40 centimeters in length and placed them adhesive side down onto the table with the non-sticky tabs for convenient handling. We ran our fingers along both strips to ensure that they were firmly onto the table. Then we used the tabs of the tape to quickly peel them off. The two pieces of tape were then held away from each other and brought close enough to observe an interaction. For part C, three strands of tape were used this time. We labeled tape A as the original. We labeled it O on using a pen. And for the top tape, we labeled it T, and for the bottom tape, we labeled it B. Each tape were also 40 centimeters in length. The original tape strip A was placed adhesive side down onto the table with the non-sticky tab also for convenient handling, and for the bottom strip, tape B, it was placed adhesive side down onto the table with the non-sticky tab as well. And for top strip was labeled T and was added directly above tape B. The joint of tapes T and B were quickly peeled off together as one unit and then ran our fingers across the adhesive side to remove the charge. Using the tabs created on previous tape T and B were separated from one another, and the interaction between the two tapes were observed and recorded. Using the tab, original tape O was quickly peeled off and brought close to tape T, and their interaction was observed and recorded. The same process was repeated and followed for tape B. So for data analysis, for part A, the tape was repelled from the paperclip. The tape repelled the paperclip, the spiral of the planner, the metal tip of the pencil, and when we tested the planner's plastic surface, we noticed that there was no reaction. And for prediction, we did predict that the tape will attract to the paperclip and repel to the pencil and planner. I could see it kind of attracting to the pencil. So for part B, the two strips were peeled off at the same time, and we noticed that they repelled each other just as we predicted. In in part B, when we brought them close together, that's exactly what happened, and they pushed away from one another instead of sticking together. So we tried it from two angles, from above and the bottom, to see that the air is not affecting the results that we are seeing. So for both, we did notice that they were repelling each other and that the wind was not a factor of these interactions. So for part C and D, we labeled three strips of tape. We called one O for the original, T for the top tape, and B for the bottom tape. When we placed and when we separated tape T and B, we noticed that this gave them opposite charges because they attracted one another when brought close together. Then we compared it with the original strip, and we noticed that the original strip was attracted to the top tape but repelled the bottom tape. This shows us that the top and bottom tapes had opposite charges and that the original tape shared the same charge as the bottom strip. So this just shows that each strip do not carry the same type of charge. So to analyze this, why did this happen? When the tape is peeled off the surface, electrons transfer between the tape and the table. One surface becomes either slightly more positive or negative. And this is the same principle that we see in this experiment. Two objects with like charges will push away from one another because the electric fields repel it. Opposite charges, on the other hand, will pull toward each other because their electric fields attract. And this experiment gave us a simple way to visualize these invisible forces.
Are the attractive ones.
And then
Right?
that
These are
one.
repelling. Oh, but it kind of likes this one.
That's what's this original and then
This
T.
is top, yeah.
Okay.
It likes the top one,
Yeah, and
but
then
it don't like the bottom one.
and original and bottom don't attract,
But these do.
but bottom and top do.
Are the attractive ones.
And then
Right? Now they attract.
So they attract, and then you're gonna test. You're supposed to test.
Now they attract.
So for our conclusion, in this lab, we saw how charges can be created and how they interact with one another. By pulling tape off a surface, we are able to observe attraction and repulsion, similar to the way magnets or a balloon rubbed on hair works. Our results showed us that objects with like charges will repel, while objects with opposite charges will attract. For an example, the two strips pulled off the table at the same time repelled each other, while the top and the bottom strips attracted once they were separated. The original tape strongly repelled the bottom strip, but it was strongly attracted to the top strip, showing that they carried opposite types of charge. And this qualitative experiment gave us direct evidence of one of the basic principles of electrostatics, that opposite charges will attract and like charges will repel. Electron charges always exert forces on one another, and the direction of the force depends on whether the charges are the same or different. Our experiment directly confirmed and helped us visualize this principle on a simple hands-on way. And for our credits, each one of us participated equally in this experiment. Thank you.